Hello learners, in this module we will see the components of reference architecture of a data warehouse. The data warehouse architecture is based on a relational database management system that serves the functions as the central repository for informational data. Operational data and processing are completely separated from data warehouse processing. This central information repository is surrounded by a number of key components that are designed to make the entire environment functional, manageable and accessible by both the operational systems that source data into the warehouse and by end-user query and analysis tools. Typically, the source data for the warehouse is coming from the operational applications. As the data will enter into the data warehouse, it is cleaned up and transformed into an integrated structure and format. The transformation process will involve conversion, summarization, filtering and condensation of data. Because the data will contain historical components, the warehouse must be capable of holding and managing large volumes of data as well as different data structures for the same database over time. Next, we will see what is a data warehouse database. The central data warehouse database is the cornerstone of the data warehousing environments. This database is almost always implemented on the relational database management system technology only. However, this kind of implementation is often constrained by the fact that traditional relational database management system products are optimized for transactional database processing concept. Certain data warehouse attributes such as a very large database in size, ad hoc query processing and the need for flexible user view creation including aggregates, multi-table joins and drill downs have become drivers for different technological approaches to the data warehouse database. There are several approaches and these approaches include parallel relational database designs used for scalability that include shared memory, shared disk or shared nothing models implemented on various multiprocessor configurations such as symmetric multiprocessors or SMP, massively parallel processors or MPP and or clusters of uni or multiprocessors. Another approach is an innovative approach to speed up a traditional RDBMS by using new index structures to bypass relational database scans. Multidimensional databases that are based on proprietary database technology, conversely, a dimensional data model can be implemented using a familiar RDBMS. Another approach is a multidimensional database that are designed to overcome any limitations placed on the warehouse by the nature of the relational data model and that will enable online analytical processing that belongs to a group of data warehousing components jointly categorized as the data query, reporting, analysis and mining tools. Now let us see the tools that are used for sourcing, acquisition, cleanup and transformation. A significant portion of the implementation effort can be spent extracting data from operational systems and putting it in a format suitable for informational applications that run off the data warehouse. The data sourcing, cleanup, transformation and migration tools will perform all of the conversions, summarizations, key changes, structural changes and condensations needed to transform disparate the data into information that can be used by the decision support tool. They produce the programs and control statements including the COBOL programs, MVS job control language that is JCL, Unix scripts and SQL data definition language DDL that are needed to move the data into the data warehouse for multiple operational systems. These tools also maintain the metadata. Now let us see the functionalities. The functionality includes removing unwanted data from the operational databases and the next one is converting to common data names and definitions. The third point is establishing defaults for missing data. And finally, accommodating the source data definition changes. The data sourcing, cleanup, extract and transformation and migration tools have to deal with something significant, and the issues include database heterogeneity and data heterogeneity. Now we will see what is database heterogeneity. In database heterogeneity, there are several database management systems that are very different in data models, data access language, data navigation, operations, concurrency, integrity, recovery and many other details. Now let us see what is data heterogeneity. Data heterogeneity is the difference in the way data is defined and used in different models. For example, homonyms, synonyms, unit compatibility, US versus metric and different attributes for the same entity and different ways of modeling the same facts. These tools can save a considerable amount of time and effort. However, significant shortcomings do exist. For example, many available tools are generally useful for simpler data extracts. Frequently, customized extract routines need to be developed for more complicated data extraction procedures. Now let us look into what is metadata. Metadata is the data about data that describes the data warehouse. It is used for building, maintaining, managing and using the data warehouse. Now let us see how it is classified. Metadata can be classified into technical metadata, which contains information about warehouse data for use by warehouse designers and administrators when carrying out warehouse development and management tasks. The other type of metadata is business metadata, which contains information that gives users an easy to understand perspective of the information stored in the data warehouse. Moreover, we have to see that it is equally important that metadata provides interactive access to users to help understand the content and find data. One of the issues dealing with metadata relates to the fact that many data extraction tool capabilities to gather metadata remain fairly immature, and these have to be improved over time. Therefore, there is often the need to create a metadata interface for users, which may involve some duplication of efforts. Now we will see metadata management. Metadata management is provided by the metadata repository and the accompanying software. Metadata repository management software, which typically runs on a workstation, can be used to map the source data to the target database and to generate code for data transformations, integrate and transform the data, and control moving the data to the warehouse. As users' interactions with the data warehouse increases, their approaches to reviewing the results of their requests for information can be expected to evolve from relatively simple manual analysis for trends and exceptions to agent-driven invitation for the analysis based on user-defined thresholds. The definition of these thresholds will configure the parameters for the software agents using them and the information directory indicating where the appropriate sources for the information can be found, and all are stored in the metadata repository as well. Now, let us see the access tools used in the architecture. The principal purpose of data warehousing is to provide information to business users for strategic decision making. These users interact with the data warehouse using front-end tools. Many of these access tools require an information specialist, although many end users develop expertise in the tools. Tools fall into four main categories: query and reporting tools, application development tools, online analytical processing tools, and data mining tools. Now let us see what is the function of each tool. Query and reporting tools can be divided into two categories. One is reporting tools and managed query tools. Reporting tools can be further divided into two types, that is, production reporting tools and report writers. Production reporting tools can be companies that generate regular operational reports or support with high volume batch jobs such as calculating and printing paychecks. Report writers, on the other hand, are inexpensive desktop tools designed for end users. Now we will see the function of a managed query tool. A managed query tool shields end users from the complexities of SQL and database structures by inserting a meta layer between users and the database. These tools are designed for easy to use point and click operations that either accept SQL or generate SQL database queries. Often, the analytical needs of the data warehouse user community exceed the built-in capabilities of query and reporting tools. In these cases, organizations will often rely on the tried and true approach of in-house application development using graphical development environments such as Power Builder, Visual Basic and Forts. This application development platforms integrate well with popular OLAP tools and access all major database systems including Oracle, Sybase and Informix. OLAP tools are based on the concepts of dimensional data models and corresponding databases and allow users to analyze the data using elaborate multidimensional views. Typical business applications include product performance and profitability, and the effectiveness of a sales program or marketing campaign, or the sales forecasting and capacity planning. These tools assume that the data is organized in the multidimensional model. A critical success factor for any business today is the ability to use information effectively. Data mining is the process of discovering meaningful new correlations, patterns and trends by digging into large amounts of data stored in the warehouse using artificial intelligence, statistical and mathematical techniques. Now we will see what is the data mart. The concept of the data mart is causing a lot of excitement and attracts much attention in the data warehouse industry. Most of the data marts are presented as an alternative to a data warehouse that takes significantly less time and money to build. However, the term data mart means different things to different kind of people. A rigorous definition of this term is a data store that is subsidiary to a data warehouse of integrated data. The data mart is directed at a partition of data and is often called as a subject area that is created for the use of a dedicated group of users. A data mart might in fact be a set of denormalized, summarized or aggregated data. Sometimes such a data set could be placed on the data warehouse rather than a physically separate store of data. In most instances, however, the data mart is a physically separate store of data and is resident on a separate database server, often a local area network serving a dedicated user group. Sometimes the data mart simply comprises relational OLAP technology, which creates a highly denormalized dimensional model. For example, star schema that is implemented on a relational database. The resulting hypercubes of data are used for analysis by the groups of users with a common interest in a limited portion of the database. There are several reasons why these types of data marts are called dependent data marts, because their data is sourced from the data warehouse and they have a high value because no matter how they are deployed and how many different enabling technologies are used, different users are all accessing the information views derived from the single integrated version of the data. Unfortunately, the impression of the statements about the simplicity and low cost of data marts sometimes result in organizations or vendors incorrectly positioning them as an alternative to the data warehouse. This viewpoint will define independent data marts that in fact represent fragmented point solutions to a range of business problems in the enterprise. This type of implementation should be hardly ever deployed in the context of an overall technology or application architecture. Indeed, it is missing the ingredient that is at the heart of the data warehousing concept, that of data integration. Each independent data mart makes the own assumptions about how to consolidate the data, and the data across several data marts may not be consistent. Moreover, the concept of an independent data mart is dangerous. As soon as the first data mart is created, other organizations, groups, and subject areas within the enterprise embark on the task of building their own data marts. As a result, we will create an environment where multiple operating systems feed multiple non-integrated data marts that are often overlapping in data content, job scheduling, connectivity, and management. Furthermore, we have transformed a complex many-to-one problem of building a data warehouse from operational and external data sources to a many-to-many sourcing and management nightmare. Information marketplace contains a subset of governing body-wide data. This subset of data is valuable to specific groups of an organization. In other words, we can claim that the data mart contains data specific to a particular group. For example, marketing data marketplace may contain data related to items, customers, and sales. Data mart is confined to subjects. Windows-based or Unix Linux-based servers are used to implement the data marts. They are implemented on low monetary value servers. The implementation data mart oscillation is measured in short circuit full point of clip, that is, in weeks rather than the month or a long time. The life wheel of a data mart may be complex in the long run if its design and innovation are not organization-wide. We have seen the advantages and disadvantages. Some more points to consider are: the data marts are small in size, and the data marts are customized by the section. The source of a data mart is departmentally structured data warehouse, and the data marts are flexible. Now let us look into the administration of the data warehouse. Data warehouses tend to be as much as 4 times as large as relational operational databases, reaching terabytes in size depending on how much history needs to be saved. Data warehouse was not synchronized in real time to the associated operational data, but are updated as often as once a day if the application requires it. In addition, almost all of the data warehouse products include gateways to transparently access the multiple enterprise data sources without having to rewrite applications to interpret and utilize the data. In other words, a heterogeneous data warehouse environment, the various databases reside on disparate systems, thus requiring inter-networking tools. The need to manage this environment is obvious. Managing data warehouses includes security and priority management, monitoring updates from the multiple sources, data quality checks, managing and updating metadata, auditing and reporting data warehouse usage and status, and also purging data. Apart from this, replicating, subsetting and distributing data, and also backup and recovery and data warehouse storage management. Now, let us see the data warehouse administration tools. In these tools, DAC is the most important. DAC is Data Warehouse Administration Console. The DAC will provide a framework for the entire life cycle of data warehouses implementation, and it allows you to create, configure, execute and monitor modular data warehouse applications in a parallel high-performing environment. For more information about the DAC process lifecycle, see about the DAC process lifecycle. The DAC complements the Informatica ETL platform, and they provide application-specific capabilities that are not pre-built into the ETL platform. For example, ETL platforms are not aware of the semantics of the subject areas being populated in the data warehouse, nor the method in which they are populated. This DAC provides the application capability at a layer of abstraction above the ETL execution platform as given in the picture. Now, let us see the important DAC features. These features allow you to do many tasks. The first one is to minimize install, setup and configuration time. There is a phase in which it is being done as given in this picture. We can create a physical data model in the data warehouse. We can set the language, currency and other settings. We can also design subject areas and build execution plans. The next topic is managing the metadata driven dependencies and relationships. It is used to generate a custom ETL execution plan and also to automate changes capture for the Siebel transactional database and also to capture the deleted records, to assist in index management and to perform dry runs and test runs of execution plans. The next task is provide reporting and monitoring to isolate bottlenecks. This is done through two tasks, that is performing an error monitoring and email alerting. The next one is performing structured ETL analysis and reporting. Now, how to do the utilization performance execution technique? That is done using the following subtasks, that is automate full and incremental mode optimization rules, to set the level of Informatica session concurrency, to load balance across the multiple Informatica servers and to restart from the point of a failure. Now, let us see about the DAC repository objects. All DAC repository objects are associated with the source system container. For more information about these containers, see about source system containers and about object ownership in the DAC. The DAC repository stores application objects as a hierarchical framework that defines a data warehouse application. The DAC allows you to view the repository application object based on the source system container you will specify. The source system container holds the metadata that corresponds to the source system with which you are working on. A data warehouse application comprises the following repository objects. The first object is the subject area. A subject area is a logical grouping of tables related to a particular subject or application context, as well as the tasks that are associated with all the tables. Subject areas are assigned to the execution plans which can be scheduled for full or incremental loads. A subject area also includes the task which is required to load the subject area tables. The next one is tables. Table is a physical database table that can be defined in the database schema and can be transactional database tables or data warehouse tables. Table types can be fact, dimension, hierarchy, aggregate and so on, as well as flat files that can be sources or targets. Now, let us see what is a task. A task is a unit of work for loading one or more tables. A task will comprise the following, that is source and target tables, phase, execution type, truncate properties and commands for full or incremental loads. When you assemble a subject area, the DAC automatically assigns the task to it. Tasks that are automatically assigned to the subject area by the DAC are indicated by the auto-generated flag in the Task Style tab of the Subject Areas tab. Next, we will see what is a task group. A group of tasks that you can define because you want to impose a specific order of execution. That is called as a task group, and it is also considered as a special task. Next, we will see what is an execution plan. A data transformation plan defined in a subject area that needs to be transformed at certain frequencies of time. This execution plan is defined based on business requirements for when the data warehouse needs to be loaded on it. An execution plan comprises the following: ordered tasks, indices, tags, parameters, source system folders and phases. Now, we will see what is a schedule. A schedule specifies when and how often an execution plan runs. An execution plan can be scheduled for different frequencies or recurrences by defining multiple schedules. Now, in this picture, we can see about the DAC process life cycle. It has several phases. The first one is the designing phase. From storage, we move to the designing phase, and then we move to the other phases as depicted in the picture. The DAC is used by the different user groups to design, execute, monitor, and diagnose execution plans. These phases together make up the DAC process life cycle as shown in the picture. These phases of the process and the actions associated with them we will see now. First one is setup. In this, we will set up database connections, set up a ETL processes, and set up a email recipients. Next to setup is designing. Here we will define application in objects and design execution in plans. Next to designing, we have execution phase. In execute, we will define scheduling parameters to run execution plans and also access the runtime controls to restart or stop currently running schedules. Next to execution is monitoring. In monitoring, the runtime execution of the data warehouse applications is done and it will monitor the user's DAC repository and application maintenance jobs. Now we will see what is the information delivery system. The information delivery system component is used to enable the process of subscribing a data warehouse information and having it delivered to one or more destinations according to some user-specified scheduling algorithm. Furthermore, the information delivery system distributes warehouse stored data and other information objects to other data warehouses and end-user products such as spreadsheets and local databases. Delivery of information will be based on time of day or on the completion of an external event. The rationale for the delivery systems component is based on the fact that once the data warehouse is installed and operational, its users don't have to be aware of its location and maintenance. All they need is to report or an analytical view of data at a specific point of time. With the proliferation of the internet and the World Wide Web, such a delivery system may purchase the convenience of the internet by delivering warehouse-enabled information to thousands of end users via the ubiquitous worldwide network. Actually, the web is changing the data warehousing landscape since at the very high level, the goals of both the web and data warehousing are the same, that is, easy access to information. The value of the data warehousing is maximized when the right information gets into the hands of those individuals who need it, where they need it and they need it almost. Still, many corporations have struggled with complex client-server systems to give the end users the access they need. The issues become even more difficult to resolve when the users are physically remote from the data warehouse location. The web removes a lot of these issues by giving users universal and relatively inexpensive access to the data. When we couple this access with the ability to deliver the required information on demand, the result is a web-enabled information delivery system that allows users dispersed across continents to perform sophisticated business-critical analysis and to engage in collective decision-making. We have seen the components, the phases, and the functionalities in each phase. Now, to conclude, the data sourcing, transformation, and migration tools are used for performing all the conversions and summarization. A computer information delivery system is a system composed of people and computers that processes or interprets the information. The term is also sometimes used in more restricted senses to refer to only the software used to run a computerized database or to refer to only a computer system. Hope you had a happy learning in this module. Thank you.